All right, in these two sections for parametric equations, we're going to put them together. You're going to be looking at how a particle moves through the plane. So when it has a certain parametric equation and like which direction and it's moving in. And you're going to see how to calculate the x and y intercepts of a parametric function using their equations and also do the rate of change. Okay, so like look at this picture. Which way is a particle moving as t increases from -2 to 0? So look, here's t is -2 there, there's 0 there. So which direction is it moving? Well, it's moving left and it's up. So you want to say left and up, okay? Or up and to the left, you could say also, okay? From 0 to 3. So 0 to 3, it's going this direction here. So it's moving up and right. Okay, so as you do these problems, you have to kind of figure that out. Okay, so example 2, position of this particle. So we want to see about this one right here. So you can make this graph yourself, or remember, you can put it in your calculator or in Desmos. Yep, remember in Desmos you would put this, you would put it as a point, you would put this in the first point, and you'd put this equation here in the second one right there. So I'll just do it in the calculator because I have it here. Let's see, so I changed the mode to parametric, and then here's my equations. I got 4t plus 1, and then the next one is t squared minus 4. Right, so when you do this, like, watch how it goes, and then we want to go from -2 to 0. All right, so what I'm going to do is change my, so if I graph the whole thing right now, I'm just going to press graph and I see that. And so I want to make sure that I'm getting everything that I'm asking for though. So my window, I want to start with -2 and I want to end at 0. So let's see what happens. Okay, so I just saw that little part. So I feel like I need to see further back on the x-axis. So I'm going to change the window. My x minimum, I'm going to change that to like -10 or so, just so I can see. All right, so good. So it was moving to the right and down. So it started basically here and like went over. Another thing you could do is this, is you could, put in -2 into these problems and see where it starts. So basically -2 is going to produce this point, -7, so it's going to basically start here. And then if you put 0 into these problems, you get the point 1 and -4. So it's basically going to go down here. So it's going down and to the right. Okay, so you can kind of see the beginning and the end, and based on the picture as well. So down and to the right, so this guy. Okay, so next we're going to do some work on finding the x and y intercepts and just placement of where things are. So in the xy plane, the position of a particle is given by this parametric function, so same parametric function here, and I want to find the x and y intercepts. All right, well, if you want to find the x intercept is when the y value is 0, right? So I want to know, when is the y value equal to 0? And I have this for my y value, so I basically want to know when t squared minus 4 is equal to 0. So when I solve that, I get that t is plus or minus 2. And that's within my range right here, or my t values, so I'm going to do that. So, and also on my graph, I was able to see if I just let the window go from -2 to 3, -2 to 3, I can see that I'm looking for 2 x-intercepts anyway. So you can find it on the calculator as well. But if I plug 2 in for t, I'm going to get 8 plus 1, so I get the coordinate of 9, so 9, 0. And if I plug -2 in here, I get -8 plus 1, which is -7, and 0, which is the one we saw up here. Okay, so there's my x-intercepts. All right, now my y-intercept is going to be when x is 0. So x is 0, let's see, 4t plus 1 equals 0. I get t is -1/4. So if t is -1/4, I have to square that and subtract 4. So t is -1/4, so my x value is 0, and -1/4 squared would be 1/16. All right, so 1/16 minus 4. 1/16 and then minus 4. Now 4 is going to be 16/16, so 1/16 minus 16 over, I'm sorry, no, not 16/16, sorry. 4 is going to be 64/16. So 1 over 16 minus 64 over 16 is going to be negative 3 over 63 over 16. So negative 63 over 16. And all these things can be confirmed on your calculator as well. Like if you wanted to go ahead and look at the graph and find the y-intercept right there. So, well, I'm not sure what these calculations are going to do for you. Yeah, so they're not really going to do much for you. So I guess you could look at the table, and if one of these is nice, so right there is your y-intercept, your x-intercept. So it happened at a nice pretty t-value. So remember, the t-values don't have to be integers. They can be like decimals and stuff like that. So you just kind of luck out that you see them both here, and we're not seeing the y-intercept, so we found that ourselves. Okay, at what time is the particle furthest down in the xy plane? So furthest down in the xy plane, so it's going to be down here. So I'm looking for a minimum y value, right? So I'm looking for when this y value is at its lowest. So think about a parabola of, t squared minus 4. So this is not the graph that we were just using over here, but t squared minus 4. That is, I need to figure out when is that going to be its lowest. Well, t squared minus 4 is a parabola. It looks like this, kind of like x squared minus 4. It's at its lowest at the vertex. It's at the lowest when the x value or the t value is 0. So that's going to be my answer right there. When t equals 0, this is going to be the lowest it can be, right? Because anything higher than 0, or positive or negatives, is going to square out to a positive, and then you take away 4. So when t equals 0. So you can also kind of see that, like right here. You can kind of see it happening right there. So when you plug in 0 for t, you get the 0.1 and negative 4. So it's at 0.1 and negative 4. So that's where the vertex is right there. All right, which quadrant is the particle in at t equals 1? So I'm just going to plug it in. At t equals 1, I have the x value is going to be 4 times 1 plus 1, so 5. And then I'm going to get 1 squared minus 4, so negative 3. So 5, negative 3, it's going to be in the 4th quadrant. Okay, and so you could go ahead and just draw this over here, negative 7. This goes down to almost negative 4, a little bit above. This comes over to 9, so you can kind of draw the picture like we have on our calculator, just to kind of have it there. Okay, all right, so we've got a couple more examples, and then you got your problems to do down here, okay? So this one says you can use a calculator. It says in the xy plane, the position of the particle is given by our function right here. Which of the following describes the position of the particle? All right, so let's see. So let's go ahead and put that in. We got cosine t and t. All right, make sure our mode is in radians, and it is. Okay, so the particle is to the right of the y-axis from here to here. All right, so let's just graph this whole thing, and I want to go ahead and put these t values in here. So my window, I want to go from 0 to basically 2 pi, right? 2 pi. Okay, and I want to have my x values. I'm just going to go from like negative 10 to 10 and negative 10 to 10, just so I can make sure I see everything. So when I do that, there's my picture. Okay, so if you press trace, you can kind of follow the graph. Oops. Oh, no, yeah, there we go. So look, so there's my t value down here. So when t is 0 to 1.5, so 1.5 is right there, so it looks like that y-intercept. My graph is in the 1st quadrant. All right, so let's see. The particle is to the right of the y-axis. Okay, well, that's true. So let's check out the others. From 0 to 3.14. So 0 to 3.14, that's going to take me over here. So it's basically up to right there, 3. 0.14, like right about there. So it's basically this whole little section right here, okay? Particles to the right of the y-axis. That's not true because it came over to the left. All right, to the right of the y-axis from 1.5 to 4.7. So 1.5, oops, I'm going the wrong way. So 1.5 was right here at this intercept right here. If I keep going, if I keep making my t higher, I am not to the right of the y-axis. All right, and so there was that answer. That was correct, and I repeated here. So the next time it's to the right of the y-axis is right about here. So at 4.7, yep, this area right there. So letter D is my best choice. All right, and then number 5. I have this here, parametric function, calculate the average rate of change. Okay, so it's just going to be like another little step here. You know, our average rate of change is going to be our change in y over our change in x. So I basically need values. I need x and y values for these t values. So at t equals 1, that's going to get me 4 plus 1, so it's going to be the 5 comma 1 minus 4, or 1 squared minus 4 is negative 3. And then at t equals 3, I get 12 plus 1, so I get 13. And 9 minus 4 is 5. So once I get my points, I just do my average rate of change. So I'm going to do 5 minus negative 3 on top. And on the denominator, I'm going to do 13 minus 5. Okay? So I have 8 over, what? 8. So that would be 1. Okay? And so that's all you do. You just need your points that you would normally use like we've done before in the year, but you need them by using those t values. All right, so you have these problems to try out and do. If they have a little calculator picture, use your calculator. If not, then don't, okay? And on the very back page is the answers to check yourself with, okay? And that's it. Bye-bye.